Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in this video lecture we are going to study D flip-flop, it's a data flip-flop, and this is our third lecture of sequential logic circuits, in which we are going to study flip-flop, registers and counters. In previous video lecture we had studied RS flip-flop using NAND and NOR gate. And in this video lecture, we are going to study D flip-flop, data flip-flop. So, what is D flip-flop? It is a data flip-flop. Why D flip-flop is used? D flip-flop is used to remove the drawbacks of RS flip-flops. Now friends, what are the drawbacks of RS flip-flop? First of all, what is flip-flop? Flip-flop is a device, it is a memory device used to store one bit. It is known as a 1-bit memory cell. So it is used to store either 1 or 0, 1 in form of high voltage or 0 in form of low voltage. But in case of RS flip-flop, what is RS flip-flop? It is a reset and set. What is reset and set? Reset and set are the conditions. When the flip-flop stores the 0 bits, 0 number or low voltage, it is in reset mode, and when the flip-flop stores the high voltage or high logic, 1 logic, it is in set mode. So set and reset are the state of the flip-flop. So what's are the drawback of RS flip-flop? So in case of RS flip-flop, there are two inputs, but the flip-flop stores only the 1 bit, that is either 1 or 0. So the two inputs are required to store 1 bit. That is first drawback. Now what is the second drawback? The second drawback is that when the both set and reset inputs are high, when these both inputs are high, the flip-flop is in forbidden state. We are not able to predict the output state, whether it is a set or it is a reset. This condition is known as a forbidden condition, or it is known as a race condition. So to eliminate this drawback, the next flip-flop is invented, and this flip-flop is known as D flip-flop, that is a data. So friends, what is a D flip-flop? D flip-flop is basically a modified version of RS flip-flop. RS flip-flop is a basic flip-flop. All flip-flops are basically RS flip-flop because R and S are the states of the flip-flop. So D flip-flop is also basically RS flip-flop. So it is modified version of RS flip-flop. In this case, it has only one input, that is a data input, and this data input is connected to the set input terminal of RS flip-flop. The logic diagram or constructional diagram of D flip-flop is now going to display on your screen. From this diagram, it is clear that there is only one input, that is a D input, data input, and this data input is directly connected to the set input terminal. While the data input is connected to the reset terminals through inverter or through NOT gate. So the data input D is connected to the set input terminal as it is, while the complement of D, complement of input, that is data, is connected to the reset terminal of RS flip-flop. So now we are moving toward the output conditions. We are moving toward the working conditions. The first condition, what is the first condition? The first condition is that when data input is low. When data input is low, the set input also goes to low level because data is directly connected to the set terminals. The set input goes to low level. But the reset input is now becomes high. Why it becomes high? Because it is connected through NOT gate. So output of NOT gate, it is complement of input. So now input becomes high. So due to which the reset input goes to high level. So the flip-flop must be in reset mode. So output now becomes Q is equal to 0 and Q complement goes to high level. So Q 0, Q complement is 1. Flip-flop is in reset mode. That is our first condition. Now friends, when data input is high, obviously the set input is also high, but the reset input now goes to low level. And due to the set input, the flip-flop now is in set mode, and output of flip-flop now becomes Q is equal to 1 and Q complement is 0. So flip-flop is in reset, is in set. From the output condition, it is clear that output is same as input. That means when data input is low, Q, that is the output, is also low. When data input is high, the Q, that is output, also goes to high level. That means output follows the input. And because of this flip-flop is widely used to transfer the data from one place to another place, because output is same as the input. So data is transferred from one place to another place, and for that purpose, the D flip-flop or data flip-flop is used. Now the truth table. The truth table of D flip-flop is now going to display on your screen. From this truth table, it is clear that there is only one input, that is the data input D. The two outputs, that is a Q and Q complement. When data input is 0, Q is 0, that means output remains low, while the Q complement becomes high, 1. When data input is 1, Q is also 1, that means output is also 1, while the complement of output as a Q bar, Q complement goes to low level. That means output is same as input. So that is D flip-flop. So now the advantage of D flip-flop. The drawbacks of RS flip-flops are removed by using D flip-flops, and that's the advantage of D flip-flops. Now what are the advantages? There is only one input to store the one bit, that is the data input. So one input is used to store the one bit, that is first advantage. The second advantage, as there is only one input, there is no race or forbidden condition. That means the flip-flop, output of flip-flop in unpredictable mode is not available. We know the output state, because when D is high, output is high. When D is low, output is low. So unpredictable state is removed, is eliminated. That means the race is not allowed. Same as the advantage of D flip-flop. The first advantage, there is only one input used to store the one bit, and there is no race and forbidden conditions. So friends, this is D flip-flop, which is modified version of RS flip-flop. In next video lecture, we are going to study the clock flip-flop. So friends, thanks for watching this video lecture. Bye, take care, see you again.